Okay, so guys, very good afternoon. So it has been a long time since we have seen any video because like I was a bit busy with other classes, so I was not getting time to upload any such video, and I was just waiting for the right content because like there are many YouTube videos on almost all the topic. So I feel like if something is very interesting, then only people will actually have time to watch about it. So, nevertheless, I have like I will try my best to upload more videos as much as possible in the coming time. So today, basically, we are going to talk about a very easy topic. Okay, so under redox reaction, actually, the topic that we are going to talk about today is talks about structures, mostly like those structures where when you draw the structures, there is a concept which comes out which is called as the peroxide linkage. So basically, when the simple formula is there, in order to determine how many peroxide linkages are there and how many oxygen atoms are there in the given structure which have peroxide bond. So guys, when you would have been reading this chapter redox for the first time, or when you would have been taught by this by your faculty, so you would be knowing that in oxidation number, when we write the rule, actually we actually say that oxygens in the combined state are of different types. Okay, so one of the famous type in which oxygen appears is called as oxide, and in oxide it is seen that as oxygen is in combined state, it bears an oxidation number of -2. Secondly, when we talk about peroxides, which is O22 minus, this is actually peroxide. Oxygen has an oxidation number of -1. Then we have O2 minus, which is called as superoxide. In this, the oxidation number, or rather I would say the oxidation state of oxygen is -1/2, which is the average value of the oxidation number. I hope everyone is aware about the word oxidation state. Many times the word oxidation state and oxidation number are used interchangeably, but you might be knowing that for only monoatomic atoms and monoatomic ion, they are same, rather they are two different terms. And if we talk about this O3 minus, which is ozonoid, so the oxidation state here is -1/3. So these are the some very important ions related to oxygen that you would have seen if you would have solved questions related to finding of oxidation number, finding of oxidation state, or finding of the structure, right? So problem basically comes when we are given a particular question to solve, in which we are being asked to calculate the oxidation number of the underlying element. And guys, this type of problem or this type of numerical you would have seen while you are going to give any competitive exam, especially like if we talk about JEE and NEET. But nowadays, even in CBSE, they have introduced like questions where you are directly asked to find the oxidation. So oxidation number basically, so let us take a very easy example of H2SO5. Okay, and guys, this acid is called as Carros acid. Now see, there is a traditional technique when like when you find the oxidation number, you might be knowing that whatever the element is underlying, like for example here we take that as X, and if we do the basic maths part here, we can see that 2 into +1 plus X plus 5 into -2 is equals to 0. So if I calculate this, finally I get the value of X as how much? +10 - 2, that's +8. So sulfur oxidation number here is coming as +8. Similarly, if we take another acid, that is H2SO8, okay, which is also called as Marshall's acid, Okay, and here off we find the oxidation number, or better if we say oxidation state of sulfur, and when we take it as value as x, so we find it as 2 into plus 1 plus 2x plus 8 into minus 2 is equals to 0. So guys, the value of x from here comes out to be plus 16 minus 2, that's plus 14 by 2, that's plus 7. And even if you find out the oxidation number of chromium in CrO5, which is chromium pentoxide, if you take the value of chromium as x, and then if you calculate the value of the oxidation number of chromium, as easy it appears, it comes out to be plus 10. But do you know about this, guys, that whatever we are calculating here, like for a particular element, when we are finding the oxidation number, you should be aware about one very basic formula that talks about the range. What it talks about, guys? It talks about the range. What is the value of range of oxidation number or oxidation state of an element? So how do we find this particular formula, or how do we find this particular concept? So there is a formula for that, and I hope many of you would be knowing about it if you have actually studied this topic in detail. So formula is closed bracket, okay, closed bracket, valence electrons minus 8, comma, this is the lower limit, higher limit is plus valence electrons, and bracket closed. Why am I saying closed bracket here? So this has to do something with the set theory of class 11th maths, which states that if the bracket is closed, there are two types of brackets, guys. So these are the different combinations we can get out of that. So this is called closed bracket from both the ends. This is called open bracket from both the ends. This is called closed from one end, open from another end. It's called open from one end and closed from another. The basic difference here being that when it is closed, it includes the lower and the upper limit, or the lower or the higher limit, and when it is open, it excludes them. So here if you see, we have used a closed bracket, which means that I am going to include the numbers which are going to come in the upper limit as well as in the lower limit. Okay. Now for example, when we take the case of sulfur, guys, let's take the example of sulfur, because we are actually calculating for sulfur here. So sulfur, if I take the Z equals to 16, so basically, you know, like how do we do the configuration of sulfur? So let's jump to argon, which is 10. So argon will be what? 1s2, 2s2, 2p6, then it will be 3s2, and then 3p4. Now if you check the electronic configuration of sulfur, you can see that how many valence electrons are there, guys. So valence electrons, if you can calculate from here, the total valence electrons that will be coming here will be 6. The valence electrons being 6, you know that you can easily calculate the range of oxidation number of sulfur, which will come as 6 minus 8 to plus 6, and it will be how much, guys? Minus 2 to plus 6, which means that sulfur can take any value of oxidation number which lies between minus 2 to plus 6. Similarly, if you are aware about chromium, okay, chromium, so if you are aware about the exceptional configuration of chromium, I hope everyone would have heard about the topic, which is a very important topic for class 11th second chapter, that is structure of atom, when you would have read about the different quantum values. Your trainer or faculty would have told you about that. So chromium also, if you calculate the oxidation number, guys, you will come to know that chromium, that is Z equals to 24. So if I jump till here sulfur, when I wrote, I just want to make a small thing clear here, that whatever I have written here is not argon, because sulfur is 16, right? So we have jumped till neon. Neon is Z equals to 10. So that's a small mistake I did. Neon is Z equals to 10, and argon is 18 here. So here we'll write argon, that is 18. And you know that when we write 4s2, 20 and 3d4, so instead of that, I'll write the correct configuration here. So correct configuration includes 4s1 and 3d5. But nevertheless, you know how to calculate the valence electrons for sulfur, guys. So valence electrons for sulfur will be the number of electrons in ns and number of electrons in n-1d. ns plus n-1d electrons will be counted, and if you count here again it comes out to be 6. So even chromium, if you calculate the range, it comes out to be -2 to +6. So we know that we are doing some mistake, because what we have got here is an oxidation number which is exceeding these values. If you can check, guys, the oxidation numbers that we have calculated here is exceeding the values of the maximum. What we have calculated the maximum value with the help of formula, they are being exceeded in this question. So what is the mistake that we are doing? The mistake that we are basically doing here is that we are considering all the oxygen in this formula as oxides. But if you see the structure, it will not be all of the oxygen will not be oxides for sure. So how will the structure look like, and how will be the like what exactly the mistake we are doing, I'll show you. And I'll tell you one more thing, because you are going to give a competitive exam, so there will not be every structure that you are aware about. So there is a small trick that can be followed here if you can try with maximum questions that will come as a correct answer. So first I'll take, guys, Carrot's acid, which is H2SO5, and if I draw the structure of H2SO5, you can all try, give a pause to this video and try to draw the structure of H2SO5. Okay. So everyone would have tried the structure of H2SO5. I am showing you here. How does it looks like? So guys, if you can see, this is the structure of Carrot's acid, which is H2SO5. Okay, now what I'm going to do is I'm going to calculate the oxidation number of each element, taking 2 at a time, putting in a box. Depending on the electronegativity, you know that we can assign numbers to them. Let's say there are 2 atoms, A and B. So if there is a 1 bond present between them, and electronegativity of let's say A is greater than electronegativity of B, so we can assign them the numbers as -1 and +1. Similarly, if there is a double bond, we can assign them numbers -2, +2. Similarly, if there is a triple bond, we can assign them numbers -3, +3. That depends on the electronegativity, because this is what oxidation number is all about, right? It has a direct relation with electronegativity. So based on that, if I assign numbers here, guys, I'll take this 2 bonds, so I get +1, -1. Here I got -2, +2. Here I get -2, +2. Here I get -1, +1. Here I get -1, +1. Here I get 0, 0, because both are oxygen. Here I get -1, +1. So now if I take sulfur as a whole into consideration, and if I check that total, how many what will be the total oxidation number of sulfur, if I check here, guys, so it will come as +2, +4, and 2, if I add here, it will come as +6. So what exactly was the mistake that we were doing here, guys? So what was the mistake that we were doing here? If you can check, the mistake that we were doing here is, if I see how many oxides are present in this particular formula, how many oxides, I am repeating again, how many oxides are present in this particular formula. So wherever oxygen gets -2, I told you in the beginning of the lecture itself that wherever oxygen is getting -2, it is oxide, and whenever oxygen gets an oxidation number or state of -1, then it is said to be peroxide. So if I check again here, and if I see that how many oxides and peroxides were there, guys, so let me check. So -2, -2, here as a whole -2. So out of 5 oxygen atoms, guys, 3 oxygen atoms are oxides here, and for sure 2 oxygen atoms, if you would have understood where are they, I'll show you also. 2 oxygen atoms are peroxides. I'll point it out, the peroxide oxygen atoms. These 2 are peroxide oxygen atoms. So if I do the maths again, let's say if I do the maths again here, okay, so I would do the maths again here. So I will write down the formula here, H2SO5, And guys, I will take it as x and I will do the maths again. So what will I do? That 2 into plus 1 plus x plus 3 oxygen atoms are oxides. So 3 into minus 2. And 2 oxygen atoms are peroxides. So 2 into minus 1 is equals to 0. Now if you are good in maths and you can solve it in one go. So this goes out with this. And from here, what do we have? That x equals to plus 6. Can you check, guys, that whatever answer we were getting before was different from what we are getting now? Because earlier what answer we were getting was plus 8 was considering all the oxygens as oxides. But here we are not getting any confusion because we have drawn the structure. But the problem is, in the exam, when you are giving in a competitive exam, I am not sure how much time do you have to draw the structure for any given particular compound when you are asked to find the oxidation number. So there is a simple rule which follows, which I have tried on many of your compounds. Might be it is not applicable to all of them, but you can give it a try. It is like a shortcut method, you can say, right? So what is the concept is that if the calculated oxidation number or oxidation state overshoots the maximum value. What did I say, guys? If the calculated oxidation number or oxidation state overshoots the maximum value, then consider the maximum value as the present oxidation number state. What did we say? That if it is overshooting the maximum value, let's say sulfur was plus 6 and it was overshooting, you are getting plus 8. So plus 6 will be the answer because it cannot be greater than plus 6 for sure. Okay. And in order to know that how many oxides you should draw, like let's say this formula that I'm going to tell you right now is very fruitful for those who want to draw the structure based on oxidation number. Now, as I have already told you guys many a times, even in previous videos that I have uploaded, that try to find an interrelation between the topics. How redox is related to chemical bonding. Okay, people might be thinking that you cannot relate a physical chapter to inorganic or organic to like, but it is true. Many lectures of good faculties, if you see on YouTube, will come across people who relate chemical bonding with some physical chapter and that physical chapter with organic. This is the beauty of a subject actually. So again, if I take the example of H2SO5 and show you that if I want to find that how many peroxides are there in this particular formula and how many peroxide linkage are there. If you see, peroxide is oxygen atom and linkage is made up of 2 oxygen atoms. Okay. For example, in H2SO5, if I find the value of delta, okay guys, now what is delta? Delta is equals to the formula is the calculated oxidation number slash state minus maximum value. Okay, so here how much is the calculated oxidation number of state? The calculated oxidation number of state, oxidation number minus maximum value into the number of atoms of that particular element. Keep in mind that delta will be the calculated oxidation number state minus maximum value into the number of atoms of that particular element, and here our element of interest is sulfur. So if I put this into formula, guys, what do I get? Any idea? I get the calculated value that I have already got is 8 minus 7, and how many atoms of sulfur are there? 1. So my delta value comes out to be 1. Now if you want to find the number of peroxide linkage here, okay, I hope everyone has understood how to calculate delta. So the number of peroxide linkage will be how much, guys? Number of peroxide linkage. Obviously you know that. Okay, peroxide linkage will be how many peroxide linkage or how many peroxide oxygens will be there, if I would tell you that first. Since delta value has come as 1, so number of peroxide linkage equals to, just a minute, is equals to 2 times delta. Like for example, if you can see here, there are two oxygen atoms which are actually having a charge of, sorry if I say charge, it's the oxidation number of -1 on them. So this is the number of peroxide atoms of oxygen that we have got here. Okay, so it's a very important technique you can use, and you know that if there are two oxygen atoms, okay, for sure if there are two oxygen atoms, guys, then you can easily calculate the peroxide linkage which is present between them. That is the total number of peroxide linkage. Now for example, if I take one more example here, and let's take the example of Marshall's acid H2S2O8, and let us underline sulfur here. So you have already calculated the value of X, and the value of X has come out to be how much, guys, you have calculated from here? Can you tell me what value have you got when you did it for H2S2O8? You got it as +7. Okay, just a minute, I have done one mistake here. This value, okay, the calculated maximum value was +6. So 8 minus 6 into 1. 8 minus 6 is 2, and 2 ones are 2. So delta value is 2. Okay. Now number of peroxide atoms of oxygen is equal to delta, and number of peroxide bond, or you can say number of peroxide linkage, is equals to delta by 2. Okay guys, here it should be 6, right? Because maximum value is not +7. The maximum value that was calculated here is +6. Sorry for that. Now if we start with the same concept here for H2S2O8, we have got the X value as +7, which is again, you know, the mistake, and answer will be +6. Even if I don't draw and show it to you, you should be very much confident about it that the answer will be +6. But let me draw and show it to you here. If you draw the structure of Marshall's acid, okay, so guys, this is the structure of Marshall's acid. If you draw this -2 + 2, -2 + 2, -1 + 1, -1 + 1, +1 -1, 0 0, -1 + 1, -2 + 2, -1 + 1, +1 -1, -2 + 2. Now if you take each sulfur atoms together, like say this one, so 2 4 + 6, and here also if you take it, it's how much coming, guys? +6. So you know that +6, okay, +6 means even if I calculate the average oxidation number, which is actually the oxidation state, so how much will it come, guys? 6 + 6 + 6 by 2, total 12 by 2, that is +6. Now how many oxides and how many peroxides? By the structure, if you can check and tell me. Number of oxides. Out of 8 oxygen atoms, everyone would be easily telling me now that the total number of oxides are 6, and number of peroxides are how many, guys? Tell me. Number of peroxides are 2. So if I redo the maths again, what will be the value that I will be getting? 2 into +1 plus 2x plus 6 into -2 plus 2 into +1 is equals to 0. Cancel it off. 2x equals to +12 and x equals to +6. Bullseye. I got it +6, but many of you would have already answered and told me that it is +6. based on the concept that I have told you, that if it overshoots the value, go with the maximum value, isn't it? Now tell me the formula that I have told you here, how to find delta. Can everyone recheck the formula fast and tell me that delta is equals to the calculated oxidation number or oxidation state minus the maximum value, which is in the case of sulfur plus 6, into the number of atoms of that particular element will give you the value of delta, and the number of peroxide atoms of oxygen will be delta, and number of peroxide linkage will be delta by 2, making it that easy. If I have asked you to calculate delta here, how many of you have already calculated delta, guys? So delta is equals to maximum value that you have calculated, sorry, the calculated value is plus 7 minus the maximum value, which is plus 6, into how many sulfur atoms are there. Let me show you the formula here again. So sulfur atoms here are 2. So if I do the maths here, so it is 1 into 2, that is 2. Delta value is 2, right? So how many number of peroxide oxygen, if I ask you guys, how many oxygen atoms are there, peroxide atoms of oxygen, or how many peroxide oxygen atoms? Or simply if I ask you how many peroxide oxygen is there in this, you will for sure say that delta, that is 2. And how many peroxide linkage are there? Tell me fast. How many peroxide linkage are there? Delta by 2, which is 1. We have already proved that. Now you, with the help of this, you can draw the structure. You can try drawing the structure. See, lot of information you can get from here. Drawing the structure is up to you. But the question is it necessary for me to draw the structure to get the correct answer? 90 or 85% of the times, no. Yes, it's very good if you are trying to draw the structure. You can draw the structures and easily get the answer, that is true. But there are complicated diagrams, there are complicated structures which will take a lot of time, and it will be at the end you will feel like even if I would have saved the time by not drawing the structure, it would have been beneficial for me. Like for example, like if they ask you how many in the structure P4O10, how many POP bonds are there? How many sigma POP bonds and how many pi POP bonds are there? I mean to ask that how many single bonds and how many double bonds are there. So if I ask you like this, that if this is X and this is Y, can you tell me the answer of X square plus Y square upon X square minus Y square? Put your answer in the comment. Let me check how many of you can give this answer, which just has to do nothing with this chapter. It's a separate topic, but guys, let's see. Okay. Now CrO5, I'll tell you one more concept, like one more structure that we have taken in the beginning of the lecture. CrO5. This is called as has a very important structure, chromium pentoxide, and it has a butterfly structure actually. What type of structure it has, guys? It has a butterfly structure. What is the meaning of butterfly? I don't think I should tell you that. But yeah, butterfly structure, why it is called that, we have to know. And the problem here was we were getting the X value as plus 10. And when we calculated using the formula of range, we saw that it should come as plus 6. So what was exactly the mistake that we were doing, guys? So we need to check that. Okay, so let me draw the structure of CrO5 and show it to you. CrO5. And I hope now you will understand why it is called as a butterfly structure. Very correct. Now guys, start the numbering. Minus 2 plus 2. Plus 1 minus 1. Minus 1 plus 1. Minus 1 plus 1. Minus 1 plus 1. And each oxygen atom, because of itself, gets 0. Now if I calculate chromium, how much do I get here? 6. How many oxides and how many peroxides, guys? Fast. Oxides are 1 oxides, and how many peroxides? 4. Very good. Let's do the maths again. Hurry up. X plus 4 into minus 1 plus 1 into minus 2 is equals to 0. Can you do the maths, guys? X equals to plus 6. Bingo. Many of you would have got it before only without drawing the structure. And you would have said, yes, this is the correct answer. Because if it is overshooting it, the maximum value is the answer. It's given in the options. Okay. So plus 6 you have got here. Okay, guys. Now, tell me, use the formula delta is equals to delta is equals to what? Plus 10 minus plus 6. So it is plus 6 plus 10 minus plus 6. So it is how much, guys? 4. Okay. So we have calculated that the total number of delta value is what? 4. So there are 4 peroxide oxygens. We know that peroxide oxygen is how much? 4. And how many peroxide linkage are there? So if I calculate peroxide linkage from here, peroxide linkage here will be delta by 2, that is 4 by 2, that is 2. So can you see how many peroxide linkages are there? So guys, like this you can practice more structures where there is a concept of oxide coming, where there is a value which has overshooted the maximum value, and you can try it. It's a trustworthy topic where I have given you both the angles of viewing the structure, the chemical bonding angle as well as the oxidation number angle. So it's up to you to choose the best method so that you can easily apply that. So this lecture notes, that like this lecture that we have prepared here, okay, will help you a lot in yes, so this will help you a lot in your initial preparation if you are on the starting stage, guys, and it will give you a very broad overview when you are in class 12th and you have already prepared for your upcoming JEE and NEET exams. So guys, just one thing I would request: subscribe the video, subscribe to the channel, sorry, like the video, and comment what all changes can be made in the upcoming video, or what all topics you want for the lecture to be, so that I can mold the chapter or particular topic in that way, because I am not willing to make videos on those topics which are very common these days on YouTube. So we will be moving towards those types of topic which are rare enough and which can be very easily used for the upcoming competitive exams or any other exams. Okay, so guys, stay tuned, and thank you for watching the videos. Have a good day.